done a little bit on, what are the rules for integration, but now we're going to start talking about, so what is this good for? What is it used for? And so when you think about this thing, integration, think that represents the sum. And it looks like an S, kind of a funny shaped S, but it absolutely is a sum. The D whatever at the end just represents the independent variable. Mainly that's going to be T, or it's going to be X, one of those types of things usually when we do it. The other thing that you're going to get is you're going to get some sort of a function in here, some sort of a curve. Okay? So you're going to get some sort of a curve. Then there's two other things that you're going to see. You're going to see a number at the bottom, which is the starting X value. So think about that as a starting independent variable. And then you're going to have a box up at the top, and that's going to be the ending independent variable. So the ending X value, or T value, whatever it is. So it defines a region. So when you think about like what does this give you, is it's going to define a region that you're going to add up the area. So really, when you're talking about a curve, it's the sum. Another way to think of it, at least in today, is it's the area between the curve and the horizontal axis. So it's the relative space. It's the relative increase or decrease, depending on if you're dealing with a positive or negative. And we're going to relate this back to the chart even tomorrow, but we got to kind of figure out, what does this look like? How do we kind of deal with this? So a lot of times generically, you would see something like this. And if I put an A here and a B here, and I have put f of t, I'll use t as the variable this time, dt. What that would mean is find and I'm going to use the word area really loosely, because in this case, area could be negative. I know geometrically area can't be negative. So find the area or relative space between f of t and the t-axis from t equals a to t equals b. Okay, so that's what that really is describing. We're finding the area, and it's really just a relative space from f of t to the x for the t-axis from t equals a to t equals b. So let me show you an example of what that might look like. It might look something like this, where if you have this, the regions A, B, and C are in the figure above. So you got A, you got B, you got C, bounded by the graph of the function f and the x-axis. So this is the graph of f. Notice that that's the graph of f. That's an important piece. The area region A is 17. The area region B is 12. And the area region C is 4. What is the value of the integral starting at -5 and going up to 5? So when you think about it, because f is above the x-axis, all the way from -5 up to 1, notice that that would be an increase in this integral, right? So that's an increase. And then it's above the x-axis again. So that would be more increase in this integral, in this summation. But then when we go below the x-axis, that would be a decrease because f is below the x-axis, so that's a decrease all the way up to 8. So when you think about like the chart, generically, I know that we usually put f prime, f double prime up here, but you wouldn't necessarily have to do it that way. Meaning, if this is the graph of f, and if f is positive, and we go back this way, that means we're going to integrate from a to b of some function f. And so when f is positive, we have an increase in the integral. When f is negative, we have a decrease in the interval when we're reading it from the left to the right. So on this particular problem, notice you have 17 right here. So like if I did this problem, if I drew this problem out, just generically, I'll do my best to draw what's listed there. It kind of comes down, goes up, down, back up, and down, and something like this, where you got A, B, and C. And notice the area here was 17, the area here was 12, and the area here was 4. So the integral from -5 all the way up to 5, which would be right to there, that's where we're going to stop. When you think about the integral from -5 to 5 on this, of f of t, or f of x, I guess this is, f of x dx, it would equal 17 plus 12. Now, let's just, for the sake of asking it, so we could do this one, 17 plus 12, and you get 29. That's the answer to this particular question right here. This is 29. We'll answer that, and I'll show you that that's the right answer. So that's great, and they shade in those areas. Let's just pretend that they asked us for the integral from -5 all the way up to 8. So all the way up to here. So notice this value up here was 8. If we asked for -5 to 8 of f dx, then we'd have 17 plus 12 minus 4, because it's below the x-axis, which means we're going to need to decrease. Because it's below the x-axis, that's negative, so that means we're going to have a decrease in space. So let me show you another problem. So take something like this one. A, B, and C, we're going from -8 all the way up to 7 right here. Okay, so -8 all the way up to 7 right here. A is 4, area of A is 4, area B is 10, the area C is 23. So I'll let you pause here and see if you can come up with the answer. But if I draw the diagram of this, a general diagram of this might be, let me do my best to draw this. You'll have to bear with me that my axes might not match up perfectly, but I'll do my best. And the area here is 4, the area here, and I'll move my thing here in a second, 10, and then 23, and this is 7, and all the way back here is -8, and the question is asking the integral from -8 to 7 of f of x dx. So here's kind of the what we have. Well, if you think about what's happening, we have that 4, which is below the x-axis, so that's really negative space, because that's a decreasing amount of space. Then we have the 10, which is an increasing amount of space. Then we have the 23, which is another increasing amount of space. So altogether, if we add those up, we would get whatever that works out to be. So I'll let you finish that. But that's the kind of the idea that we're looking at that. Now, it's great. This first one, they tell us that space. You're also going to have problems where you're given something like this. And if I look at this problem, and I don't know how great I'm going to be able to draw this, but let me see if I can. Get some graph paper and draw this out as best I can. I'll kind of try to copy this over here. So let's see. Got an axis here, and then it looks like go up 1, 2, 3, 4, 5, and all the way over to. So we'll say it's going by 2, 2, 4, 6, 8, 10. So that's negative 10. And 2, 4, 6, 8, 10. And so we're up here at 5. So let's see, we're going to go to here and we're going to go all the way to right there roughly. Then it goes down to 2. Oops, not quite that far. It goes down to 2 at 2. So let's see. This goes like that. Then it goes all the way out to 3, 2, 4, 6, 8, 10. So it goes out to 3 there. Then it goes up to 4, out at 6. And then finally it just goes over to 9. So something like that. I know my graph goes by 2s, but in the end, when we're asked to do, on this problem, we're asked to do the integral from negative 2 to 9. So negative 2 is right here. 9 is right here, roughly. So what we're looking at there is we're looking at the space underneath here, that triangle, and then we're looking at the space in that rectangle. We're also looking at the space in this triangle. So we're going to find the areas of those things. So when we go through finding the area of those things, we might do, so this is the integral of f of x dx. And so we're going to do the first one, and that first area is 1/2 3 times 2. Second triangle is 1/2 3 times 4. And then the rectangle is 4 times 3. Whatever that comes out to be, that would be our calculation. Now technically you have all the information you need to do the rest of this assignment. I'm going to do one more example, but you have the rest of you could do the rest of this from here. Okay, so let's see if I can get a new problem. And actually I'm going to go back and get the second one. So notice this one is a little bit different. Where this one is going down here, and it's negative. It's got some negative values in there. I'm going to do my best. I got a better grid here now this time. So I'm going to redraw this one. Let's see, it looks like I need to go up to about 7. I think that'll do it right there. Okay, so negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's negative 9. And it looks like we go up to 5. So 1, 2, 3, 4, 5. So we'll make sure that we go up to 5. So that's 6, negative 6. So it go up to here. Then it looks like we go down to -5. 1, 2, 3, 4, 5. So there's -5. And it looks like we go all the way down to 4 at -5. So we go all the way down to something like that. And then it comes over to 1. And then it goes up to -3, 4. 3, 4. And then finally it goes over to 9. 5, 6, 7, 8, 9. And the question is asking us to go from -6 to 4. Okay, so the question is asking us to find the integral from -6 to 4 of f of x dx. Now, if we do that, -6 starts here. So notice we're going to have that space. Then we're also going to have, we could kind of think about that space right there. Notice that those two green ones would really go, they're the same. So they're going to go away. We got the space right here in this rectangle. Then finally, we got the triangle or the trapezoid that goes out to here. So all in all, we're trying to find this orange space here. So we could break this into different sections if you wanted to. We could break this into sections by saying, okay, we know that this section is 1/2 1 times 5. This section is -1/2 1 times 5. Now it's negative because it's below the x-axis. That's that section. This next section right here is negative also because it's below the x-axis, and it's 1, 2, 3, 4, 5 times 5. And then finally, if you calculated this one, you really could count the boxes in this, and you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is 12. So notice you could count the boxes in there, but this one's negative as well. So if we wanted to calculate this, we would have this whole integral would be 5/2 minus 5/2 minus 25 minus 12. And that would give us the rest of that. That would give us the integral up to there. I think that should suffice to get you to where you can calculate all these integrals. If you have questions, let me know. I don't want to make this video any longer than I've already made it. So if you get stuck, let me know.